Let's get started. Hey, London. Super excited to be here. So, a little bit of myself. I'm Zhao, and I wear two hats. My open source hat, I'm the maintainer of Envoy Gateway project. And also I contribute to Envoy. And also have another hat. This one, my company, okay. I'll just wear this one. So although this might not be the flash topic like generative AI, LLM, it's a little boring, no? Security stuff, very old. But I think we can all agree that securing the gateway traffic is super important for any of your application. So it's definitely something worth talking about. Today, we are going to dive into some advanced security policies for Envoy Gateway. I'll also give you a quick demo on how you can use it for OIDC authentication and authorization. Okay, let's jump in. First, I saw some friends from our community, so I'd like to do a quick poll. How many of you have used or played with Envoy Gateway on your laptop, or maybe testing? Can you show me your hands? Oh, thank you, a bunch of them. Are there anyone already put it in production? Anyone? Okay, I say 1, 2, 1, 2, 3. Oh, awesome. Love to say that. So, if you are not very familiar with Envoy Gateway, it's just a control plane to make it much easier for you to run Envoy proxy as an API gateway. That's it. We know how hard it can be. You know, if you like run Envoy as a proxy by manually configure them, it's like tens of thousands of YAML files. It's a disaster. But instead of manually configuring Envoy, Envoy Gateway just uses the Kubernetes Gateway API to help you set up and configure the Envoy proxy automatically, whether it's a standalone service or inside of Kubernetes, so without all the hassle. So basically, it's a simple way to manage and handle the gateway traffic for you. And today, our focus is security policy. Security. So what exactly is that? Or more broadly, what do we mean by a policy, right? So we mentioned that Envoy Gateway uses Kubernetes Gateway API, which is a standard. And Envoy Gateway is one of the implementation. So that's it. And one of the coolest things I love about the Gateway API is the idea of policy attachment. Basically, you can define your own traffic policy and attach them to the core gateway API resources like gateway, HTTP route, to enhance its capability, to add your own features, but without necessarily modifying those core resources directly. So that's a very powerful, very flexible way to extend how the gateway API standard works. And that's exactly how security policy works. So you just define your security policy. It's maybe like 10 lines of YAML file, that's it. And Envoy Gateway will take care of all the rest. And what security policy can do, okay? All the aspects of your gateway traffic security. First, of course, you can define which origin can access your backend API. So if you have ever developed a front-end application, okay, you made an API call from your JavaScript, boom, you hit with some random browser restriction or messing things up, right? But with security policy, you can just define which origin can access your backend. You don't have this whole worry about that. Then authentication. You can define who can access your system. We support HTTP basic auth, very old, simple way. but sometimes still used. And the JWT token, more secure, more scalable way. And API key authentication, very good for machine-to-machine access control. And OIDC, it can be used with any standard OIDC identity provider. After user gets in, you can define what they can do. You can control what they can do in your system. We support fine-grained authorization. Security policy allows you to identify user based on their client IP, JWT claim, basic auth username, ATP header, and method. And it can allow or deny access to any specific API route based on rules. And last but not least, if you have your own authorization system, okay, you have some very specific requirement. We can certify you, so you can just hook it up with Envoy Gateway by using Ext Auth. So let's take a look on how security policy works. It can be applied at 2 levels. First level, gateway level, which means you can define one security policy and apply it to the gateway level. And all the routes under that gateway will get protected. So don't worry about it. You can also define another security policy. For example, you may have an endpoint which is very sensitive, can only be accessed by administrator. So you can define another security policy and apply it to that specific route to override the global one. So this two-level structure is very flexible and powerful. Let's break it down with an example here. On the left, the very simple gateway, we define gateway named EG, which handles incoming ATP traffic at port 80. In the middle, we have an HTTP route, which under this gateway to direct the traffic to the full service at port 8080. And on the right, most important part, we have a security policy. So we define OIDC authentication. So it's very simple. It's just like 80 lines of YAML file here. So we specify the provider, client IDs, client secret, which you can find the information in your provider's configuration page. And then we add a authorization rule. Okay, only the request from this client IP address can access our backend. So with this simple setup, you can only the authentic user from this particular subnet can access our system. All the other requests will be denied. Here are some more examples. For example, CORS, you can define the allowed origin, allowed header, allowed method, and expose header. And basic authentication, you can authenticate user using the username and password stored in a Kubernetes security. And you can also extract API key from an HTTP header and use the API key stored in a secret to verify against it. Okay, next I will give a demo on how you can use OIDC authentication with Amazon Cognito. But before that, let's quickly walk through this demo so you can understand how it works. First, administrator create a security policy using Amazon Cognito as the identity provider. And once it's created, Envoy Gateway just picks up and translates it into Envoy configuration and apply it to the Envoy to the proxy. And once the user request come in, if the request doesn't have an ID token in it, so because authentication is required, so Envoy proxy will redirect the user, will block the request and redirect the user to the Amazon Incognito authorization login page. And user needs to input their username, password, or whatever credential required by this login process. Then, after successfully logging in, the user gets sent back to the Envoy proxy with an authorization code. And the Envoy proxy will use that authorization code to exchange an ID token by communicating with the Cognito token endpoints. So that's how OIDC works, right? And this ID token can prove the user's identity. So user get authenticated, and the request will be processed to the backend. So that's how it works. We can say with this setup, only all the login is handled by the Amazon Cognito, and the redirect, the ID token exchange, and the access control are handled by the Envoy proxy. So all these are transparent to our application. Okay, let's go into a demo. I hope everything works well, because we know the conference Wi-Fi lasts so good, so let's jump in. Okay, I do have like a kind of cluster on my development machine preloaded, because I know this Wi-Fi lasts so good. And let's see, here you can see this space. Envoy Gateway System. That's where the Envoy Gateway is installed, okay? And this is the actual Envoy proxy, which will handle your incoming traffic. You don't have to spin up by yourself. If you just create a gateway resource, and Envoy Gateway control plan will set up this proxy for you automatically. And then let's see here. So if we go to the default namespace, we can see I already installed the backend application. That's a demo application. Let's just ignore Kcloak here right now, because that's a demo I will show later, okay? And then let's see gateway, okay. Here we define a gateway which is listening on the port 443, handles HTTPS traffic. And we also have HTTP route. Yeah, this one, my app. So we can say this route's parent is EG Gateway, so it's under the EG Gateway, and we just have a very simple rule to route the traffic, which matches the my app prefix to this backend service. And the most important part, security policy. This one. Okay. So if you look at here, so this is target, which means the security policy will be applied to this particular HTTP route. And this is a key part, OIDC authentication configuration. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 times now YAML file, that's it. So basically, you have a client ID, which you can get from the Amazon Cognito configuration page, and you have a secret we store it in a Kubernetes secret object. And Actually, quickly is not necessary if you just do authentication, but later I will also show how to use it for authorization. So I specify the quickly so I can later to get some crucial information about the user from that cookie. So I set up a quickly here and logout path, provider, issuer. So all this you can get from the Amazon Cognito configuration page. Okay. Oh, that's it. Let's try it. Oh, hope everything goes well. I'm so nervous. Oh, boom. What happened? My God. Oh, I'm relieved. So we can say actually we head into the gateway port, but gateway redirect us to redirect me to the Amazon Cognito login page because I don't have like ID token in my request. Then I input my credential here. Oh. Oh, okay. Everything goes well. So that's the power of 11.9 of YARN file, OIDC authentication. Okay, now we get authenticated, and what happens next? So we know we get an ID token returned by the identity provider. For example, this is a JWT token returned by the Amazon Cognito. So we can see here every key pair is actually called claim, which holds some information about the authenticated user. For example, sub is the unique ID of this user, and email is the verified email. So you can use this information to enforce authorization right at the gateway level. For example, we have a security policy on the right. We can say how we use this information in our security policy. So we just say, okay, if the sub claim is this unique ID and the email is this email, then we allow access. Otherwise, will be denied. Let's try it. Okay, I'm gonna quickly apply this. Okay. Already changed it. Okay, we can see here. So let's scroll down. Okay. So the original OIDC part is still there, but we have some new section here, like JWT. What this means? It means that okay, we get an ID token from this particular cookie, and we decrypt this cookie and get all the claims from the cookie. Then we use it for authorization, this part. So if the sub is this ID and email is this email, we can access. Okay, let's try it. Oh, last happened. What happened? Because it's my email, so it's expected. But let's change it. Let's change it to another email maybe. So let's change this email. Remove this. Okay. Let's try it again. Okay, so because the email doesn't match my ID token, so I was denied. So that's authorization. So, but not only JWT claim, you can also use JW scope, and you can also combine other conditions like probably current IP address. Yeah, you can also use that. Okay, let's continue this. So just now we saw how OIDC authentication work with Amazon Kubernetes, which is a managed service. But sometimes you might want more control over your identity provider. So you choose to deploy an open source solution, maybe Keycloak. So it's within your own organization. You have more control. And sometimes you may choose to use self-signed cert for it because you use it for testing, or because you don't need a public CA. In that case, you can use a backend test policy to specify the CA cert for the Envoy Gateway to establish a test collection with Keycloak. Oh, okay. So on the right side, we can inside the security policy, we use another Envoy Gateway resource called backend, which we use it for communicating, for sending traffic to outside of the Kubernetes. So, and we also create a backend resource here called backend Keycloak. And in that backend resource, we define the hostname and port of this Keycloak. And in the backend tier policy, we specify the CA cert from a config map. So that's how it works. So with this setup, the Envoy Gateway will use the provide CA cert to establish test collection with Keycloak. But actually, this here in my setup, the backend is not necessary because I deploy Keycloak within the same cluster of my Envoy Gateway. But if you deploy the Keycloak outside your cluster, maybe in your virtual machine or another cluster, you can reach it with, through Kubernetes DNS, so you might need this. So just for example, and try it. Okay, so I already deployed Keycloak within my cluster, and let's see the security policy. So I have another security policy here. So very similar to the previous one. The only difference is that, okay, the provider is a backend resource instead of a URL to like Amazon Kubernetes. And you can also define some other traffic policy. You can like define retries for the collection with Keycloak, something like that, yeah. Okay, that's it. I'll try it. Oh, okay, I also need to show the route. Because this route, this target of this security policy is this HP route, length 4, so it says this route. So, okay, so any request send it to example can match this prefix will be controlled by this security policy. Let's try it. Okay. Yeah. Get it. Okay. Yeah. Luckily, it succeeded. So that's pretty much my presentation today. And here are some key takeaways. So what a security policy can do here. Yeah. And you can, I do have the demo, the script, the YAML file in this GitHub repo. So definitely download and try it out. It takes like 5 minutes if you want to try it out. And also, our friend from Docker, they already put Envoy Gateway into production. So if this is something you are interested in, so definitely check it out across the hallway and that room. It will be next presentation. Thank you.